Okay, raise your hand if you've been here. You start a coding session with your AI, and honestly, it feels like pure magic. But an hour later, it is outputting absolute slop, forgetting your basic instructions, and making wildly stupid decisions. So, why does your AI get dumber the longer you code? Hooked yet? I know the pain, because I have literally lived it. Let's dive into this. Welcome back to the Explainer, Devs. As an AI engineer, I've got to tell you a hard truth. AI is an incredible new paradigm, absolutely, but throwing our software engineering fundamentals out the window is a massive mistake. Today, I am giving you a masterclass on a highly structured AI coding workflow. We are going to stop lazy vibe coding right now, and we are going to start actually engineering our AI. To engineer our AI, we first have to really understand its weird constraints. Dex Hyland over at Human Layer maps this out brilliantly with the concept of the smart zone versus the dumb zone. When you fire up a fresh conversation, the AI is sitting pretty in the smart zone. The attention relationships between the tokens are completely unstrained. But as you dump more and more code and context into that chat, you just drag the model down into the dumb zone, and its logic completely falls apart. And this quote beautifully illustrates exactly why that happens. Think about a football league. Every single time you add just one new team, the number of matches you have to schedule scales quadratically. Well, large language models work exactly the same way. The positional and attention relationships between every single token compound massively. You are literally exhausting the AI's ability to focus. So what's the actual limit here? It's 100,000 tokens. That is the hard cap for the smart zone when you are actively coding. And look, I know exactly what you're thinking, but my model has a 1 million token context window. Listen, those massive context windows are fantastic if you're just retrieving information from some giant document. But for complex, logical coding tasks, if you push past 100K, you are officially coding in the dumb zone. Now, devs love to try and fix this by compacting their chat histories. Asking the AI to summarize the chat so they can keep going. Seriously, stop doing this. All you're doing is compacting bad memory and sediment. Instead, you need to treat your LLM like the guy from the movie Memento. Every time you finish a small task, completely clear the context. Reset it back to a tiny, baseline system prompt. Stay in the smart zone. Phase 1, the Grill Me alignment. To build a real workflow, we need a human in the loop for the planning phase. But before we even plan, we have to destroy this highly toxic idea, the specs to code movement. This is the fantasy that you can write a massive text document, feed it to an AI, and it just magically spits out a perfect app. And if the app breaks, you just endlessly tweak the text specs and ignore the codebase entirely. Guys, this is literally just vibe coding by another name. The code is your actual battleground, and you must keep a handle on it. So how do we actually align with the AI without writing some massive 50-page spec? We use the Grill Me prompt. You clear your context, give the AI a rough idea of the feature, and you command it to relentlessly interview you. The AI spins up sub-agents to explore your codebase, and it fires specific architectural questions at you, one by one. By the end of this intense back and forth, you and the AI have reached what software pioneer Frederick P. Brooks calls the design concept. It's a deeply shared, highly accurate understanding of the goal. Phase 2, vertical slices and tracer bullets. Now that our AI understands the exact feature we want to build, we have to turn that alignment into actionable, grabbable tasks. We do this by asking the AI to summarize our Grill Me session into a product requirements document, or PRD. This outlines the user stories, implementation decisions, and testing specs. Now, here is a massive pro tip from an AI engineer. You don't even need to read this document. Seriously. Why? Because you've already reached a shared design concept during the grilling session. This document is really just testing the LLM summarization skills to create a concrete destination. Next, we ask the AI to break that PRD into manageable issues. But keep in mind, AI naturally wants to code in horizontal slices. It wants to build the entire database layer, then the whole API layer, and then the UI. If you let it do this, it gets absolutely zero feedback until the very end. Instead, you must force it to use vertical slices. In the classic book, The Pragmatic Programmer, these are called tracer bullets. You build a thin slice of the schema, API, and UI all at once. This gives the AI the instant feedback it desperately needs to know it's actually on target. So the crucial point here is how we organize these tracer bullet issues. If you ask an AI for a plan, it's going to give you a sequential phase 1, phase 2, phase 3 list. And that means only one AI agent can work at a time. Instead, tell the AI to generate a Kanban board. This 20-year-old engineering concept creates a directed acyclic graph of independent issues. By establishing clear blocking relationships up front, you instantly unblock parallelization. Phase 3, the AFK night shift. Unblocking those parallel agents brings us to the absolute climax of our workflow. I like to think of this as the division between the day shift and the night shift. Everything we've done so far, the grilling, the designing, the PRD, the Kanban board, all of that was the day shift. It required a human in the loop. But actual code implementation, that is a night shift task. You queue up those Kanban issues, step away from the keyboard, and let automated parallel agents take over completely. To actually execute this night shift, we use a Ralph loop, often powered by a TypeScript library like Sandcastle. I completely geek out over this because it's an incredible pipeline. It automatically spins up isolated Docker sandboxes for each Kanban issue. It passes the markdown issue files right to the AI, instructs it to prioritize bugs and tracer bullets, lets the agent churn through the implementation, and then automatically merges the branches. You can literally have a small army of agents coding in parallel while you sleep. How cool is that? Phase 4, TDD for AI feedback loops. But wait a second, how do you prevent these agents from merging total garbage while you're away? You enforce test-driven development, or TDD. When an agent picks up a task, it must first write a test that fails. That's the red phase. Only then does it implement the code to make it pass, the green phase, before finally refactoring. Why is this absolutely mandatory for AI? Because if you let an AI write the code first, it is gonna cheat. It will write a terrible, shallow test just to ensure its flawed implementation passes. TDD forces honesty. I need you to internalize this fact right now. Feedback quality is the absolute ceiling of your AI's coding capability. If your codebase lacks strict types and rigorous test boundaries, your AI is essentially coding blind. It genuinely doesn't matter what prompt you use. A bad codebase will always yield slop from your agents. Phase 5. Deep modules fix bad agents. So, to make all of this work, how do we structure a codebase so our agents actually succeed? We turn to John Ousterhout's philosophy of software design. He contrasts shallow modules with deep modules. Shallow modules are dozens of tiny files with tangled dependencies. They confuse the hell out of AI because the test boundaries are basically impossible to define. Deep modules, however, are massive chunks of functionality hidden behind a very simple, clean interface. They provide huge, easily testable boundaries that AI agents can actually understand and verify. And this unlocks a transformational mental trick for you as an AI engineer. You run an AI skill to scan your architecture and cluster those tangled files into deep modules. Then, here's the real secret. You, the human, design the high-level simple interfaces for those modules. You retain your sanity and your grasp of the system. But you delegate all the dense, complex implementation inside those gray boxes entirely to the AI agents. You act as the architect, the AI acts as the builder. So we've covered the smart zone, the grilling alignment, automated sandcastle pipelines, and deep modules. So I leave you with this question. Are you going to keep treating AI like a magic 8-ball, endlessly vibe coding and just praying it works? Or are you ready to apply real software fundamentals and actually engineer your AI? The choice is totally yours. Thanks so much for joining me on this explainer, and I'll see you in the next one.